Yeah, I gotta shave this thing. Well, hey there, everybody. Welcome again to Astronomy Daily Live. So,
Hey there,
come on in, everybody, and I've
welcome
done it again. I have not stopped this, so
Come on in, everybody.
I'm gonna stop that. Okay, there we go. Man, I don't think I'm ever gonna learn. I don't think I'm ever gonna learn that trick. Now I'm going to see if I can get this camera to focus on me a little bit better because it doesn't look quite right. What I found is if I do that, get it to focus on my ugly hand, and then go whoop, then it locks in. I think that's a little better. So, all right, well, welcome. Come on in, friends. We're doing this practically every day, starting at 2 hours UTC. Once in a while, I have to miss because of whatever. And actually, yesterday was one of those whatevers. So yeah. But I sort of knew early enough, um, and so yeah, that allowed me to sort of warn everybody, and I hope that wasn't too much of a problem. Hopefully not. We are a pretty casual group here, so yeah. So yeah, hope everybody had a good day off, and we are definitely back. Just doing the astronomy thing. Just having a lot of fun. Just sort of exploring all of this and thinking about it, and all of that. So cheers. I've got the HOH tonight. All right. Yeah, that's a nice batch. So yeah, come on in, friends. I'm going to. Oh, the one thing that I didn't do was I didn't pull up the chat. So let me try to do that. While I want to say howdy to Bobby in the panel.
Hey.
How are things over there, Bobby?
It's doing all right.
Good. Very good. Yeah, everything's good here. It's actually another clear night. Hey there, Tom. Nice to see you in the chat. Nice to see you there. Very cool. So yeah, come on in. We talk about all things astronomical. All things astronomical. So that's actually a pretty wide open subject. Astronomy is one of those sciences that is both very broad and very deep. A science like chemistry, right, is very deep, but definitely not as wide as the astronomy. So yeah, and that's one of the reasons why I greatly appreciate it, and I've liked it for my entire life. Was that there was a lot of material, right? There was a lot of stuff that sort of encompassed that.
And did you forget to tweet?
Did I forget to tweet? Yes. See, I get carried away and it doesn't happen. I'm glad that there are friends around to remind me of these simple things. All right, I have done it. All right, excellent. Thanks, Bobby.
Don't thank me, thank Tom.
Oh, is it Tom? Okay. Thank you, Tom. Yeah, sometimes I get going here, and you know, this is fun, right? I mean, I actually look forward to this every day because it's just really really fun to sort of think out loud um, about these topics that I think about pretty constantly. So it's kind of fun every day, or pretty much every day, to talk about these things. And speaking of which, I've been thinking about how to make improvements to this live stream. What'll make it um, both better, which is what I'm always after, but also sort of stand out from all the other live streams that deal with space and astronomy and all of that. What can I do to be different, right? Because I mean, if everybody's pretty much the same, then it comes down to other qualities, right? Like production quality, and you know how well the information is presented, right? How clearly the speaker speaks, right? Uh, all of those things, those qualities um, become a lot more important um, if all these live streams are basically the same, right? In terms of content and all of that, right? So I'm looking for a different kind of content that would make this a better live stream, and also you know um, make it stand out. And so what I'm thinking that I'd like to start encouraging people to do is to come on to the panel. And if I mean, you're not required, right, to have any kind of camera or anything else. Just sort of a voice, right? I mean, a voice is good enough to have a conversation, right? Which is what I would sort of like to move this live stream towards. Is actually make it, much more like a virtual porch, where all of us on the panel are sort of, back and forth, right? Just like it would be if we were all, physically together, sitting on my back porch here, shooting the breeze about all things astronomical, right? Um, so, we physically can't be in the same place, but here, yeah, we definitely can, and we can have some interesting back and forth um, that I think would be pretty pretty unique in this sort of live stream astronomy um, space. So yeah, I think I'm going to start encouraging you all to I mean, I'm I'm interested in making this channel better, and now it's really looking like I could use your help doing that. Because yeah, I think having a full panel, I think I can have 10 panelists at a time. That could make for a pretty lively discussion, right? That can go anywhere, right? Just like these kinds of things do all the time, right? Friends get together, they go out on the porch, got their consumables of choice. Cheers.
And
And
there's Anawada returned from her acting trip.
oh, Atta's back.
I was
Yay.
wondering when she was coming back.
Yeah, I think she said something like 10 days. Has it been 10 days? Wow. That's amazing. That's amazing. So, Atta, nice to have you back. Hope everything went well. Obviously, you got home safely, so it couldn't have been all that bad. Mars Insight, yeah, it's boy, that's coming up pretty soon. Yeah, I don't remember exactly when. Is it November or December?
What's the Mars Insight?
The Mars Insight is a the latest mission to Mars. It was the spacecraft was launched it was a few months ago, and it's a lander that is going to land on the surface, and it's going to deploy. I think it's deploying like three different instruments. I'm trying to remember. I can recall two of them. The first one is a seismometer that is going to be able to measure, microquakes, just the tiniest motion of the ground. They'll be able to measure. That's sort of a tricky thing. So I don't know if it's going to work or, well, excuse me. I don't know if it's going to work or not. But if it does, it's going to be kind of interesting, right? Especially if they start, hearing like, So, yeah, okay. So November 26th. November 26th, they're going to be landing. So, so one instrument is the seismometer. There's another instrument. It's they're basically going to bang this rod deep into the ground, and this rod is going to be able to measure the temperature, and maybe a few other things too. And I guess from that, they can sort of infer what the inner structure of Mars looks like. Now, to me, that's sort of a stretch, right? Because I don't remember how far down. It wasn't very far. I want to say like 3 meters or so. I mean, if that far, right? Okay, so I guess there's more than 3. Oh, okay, yeah, that's actually what I'm talking about now. Is the heat flow and physical properties probe, right? So they're going to bang this probe into the ground, bang, just walk it down there, and it's going to be interesting, right, to see how it goes in, right? Because I mean, they're going to. I mean, I'm sure that they've thought of this, right? But it's the idea. It's like, okay, how much force does it take to bang this rod down like 1 inch, right? So I mean, they'll be able to do that, right? They'll be able to actually get sort of a profile of the crust. I guess you call it the crust. Okay, it's 5 meters down. Cool. Thank you, Tom. So 5 meters. What's the diameter of Mars? I gotta ask. I'm gonna just look here. I'm not gonna show you, but I'll just look. Mars planet. So 2,106 mile radius. So let's see. I'm going to pull out the. I haven't shown you this in quite a while. Here it is. It's still working. Still working great. Well, I don't know about great. But, okay, so 2,106 miles.
They must have a way to match the signal of the pounder from the seismometer, otherwise it will go crazy, says Adelana.
Yeah, I completely agree with that. So wait, let's do 2,106 miles. So let's see how many feet that is. That's 5,280 feet. So that's 11 million feet. And a meter is about 3 feet. Okay. So let's just divide that by 3 to get how many meters, right? So it's 3.7 million meters. And they're going 5 meters down. So I'm going to inverse that and then multiply by 5. So that is going to be sampling 0.000135% of the radius of Mars. So wait, let's divide that by 100 again, and multiply by a million. Yeah, so that's 1.4 parts per million. So can they, I guess my question is, can they accurately infer the structure of Mars by sampling 1.35 parts per million? Don't know. Oh, I've got to catch up here. So
yeah, check the chat.
Check the chat. Must have a way to mask. Well, I don't think that they're going to be doing that at the same time, Atta. I think the pounder experiment is probably going to happen first, because, I think if, my thought is, I guess, is that if the seismometer is already up and running, as sensitive as it is, that kind of pounding is probably going to, melt it. So, I would think that they would do the pounding first, and then when that's done, they'll deploy the seismometer. That's just my guess. But they'll be able to get a profile, right? Depending on how hard they pound it, which they'll supposedly know, right? I mean, those kinds of things have to be calculated or at least measured, right? And that amount of force, right, is going to move the probe down a certain distance, which they'll also be able to measure. And so, you get a measure of the porosity or the softness of the soil. It's cool. And okay, so the WTS is like a separate instrument, huh? What's the WTS doing there?
To me, for an engineering viewport, the most difficult task is a safe landing.
Yeah.
I talked a lot of with Uncle Bill during concurring it.
Yeah. I totally agree, and I think everybody on this mission agrees too. If my understanding is correct, they have chosen one of the most benign places. I think. You know what? Mars Insight it is. Let's take a quick look at Mars Insight. I'll share my screen here, and we will go over to Mars Insight. Because now I want to know more. Atta, you have successfully misdirected the live stream. Congratulations. So they're expected to land on the surface of Mars at Elysium Planitia. So let's look at Elysium Planitia. That's a pretty uninteresting place. Let's really look at Elysium Planitia by going over to HiRISE. And I think there's a way to search. There is. Okay, so let's punch in that over here. Ah, here we go. I wonder if they may actually have a... Oh, no. For some reason... Well, let's do both. Let's do Elysium Planitia and Insight. Ah. Okay. Well, let's see what we've got here. Straddles the equator of Mars. 3 degrees north is its center. Elysium contains some major volcanoes. Shield volcano. Eddy, Lockyer, and Tombaugh. That it may be ash-covered water ice.
Now, have we ever learned from anything from Mars about its history and stuff by just sending probes out to Mars and stuff?
Well, one way that you can sort of study, at least the theoretical history of Mars is to look at its craters, because at least according to the current story, cratering events can sort of allow you to track the history of not only the planet but also the solar system. So yeah, there is there are efforts to look at the craters, look at their sizes.
Now there was a question from when on Christian Reddy's live stream. I was wondering if did even NASA ever fake the moon landings, or they're just the real deal?
Oh, is it possible that the moon landings were faked and that it was Kubrick? I suppose so. I mean, I suppose so, but I don't see what the big deal is, right? I mean, we went to the moon, and that was very cool, right? It's very, very cool, but it's in sort of the grand scheme of things, it's like, yeah, okay. So I don't really understand what the big deal is, whether we did or not. But my personal confidence in that is as close to 100% as possible, right? I mean, absolutely, I could not be totally certain, right? Because, Kubrick was a good director, and he had the resources to do that, for sure. He had the know-how, he had the technology. So is it possible? Sure, of course. But no, I mean, it's just a little.
If there is like any proof that these moon landings are either real or fake.
Well, I mean, we have probes orbiting the moon, photographing the landing sites, and there are the tire tracks, and there's the LEM, the landing part of the LEM. One of the things that they did is they deployed a series of retroreflectors, which you can't, at least at the time, they couldn't, automatically land those, right? So they had to be set up by people. And so, they set up a bunch of retroreflectors, which they could then, shoot a laser towards, measure the light travel time, and measure the distance to the moon extremely precisely.
And check the chat.
And so, if nobody had actually gone to the moon, why are there retroreflectors up there? So, hey there, Calvin Odbert. You have stumbled upon Astronomy Daily Live. And this is just a fun, casual get-together of friends who share a common passion for the science of astronomy. And I'm sort of the host, and each and every day, starting at 2 hours UTC, we get together on this channel, and we talk all things astronomy for about an hour or so. Usually it goes a little bit more. Sometimes it goes a little bit less. And today, one of our good friends in the chat was talking about Mars Insight, the mission that's going to be landing on Mars on the 26th of November? Yeah, on the 26th of November this year. So
Uncle Bill Duran did say that they didn't
oh yeah. Uncle Bill, I'm gonna have to maybe disagree with you a little bit.
And Captain Robert, if you can watch the language, it'll be all right. Just watch the language.
Yeah, we're doing astronomy here, so yeah. The language has to be relevant to astronomical wording. Appreciate that.
This is just a warning, okay?
So, I think that Kubrick did have the know-how and the tech to do it. I think so. The theory is, right, at least one of the theories that I've heard is that 2001 A Space Odyssey was sort of a practice, to see, that was a way to fund research for Kubrick, to see, what worked and, what didn't. You got to say, right, that the cinematography and the those, there wasn't any CGI, right? Those were all models, right, with the correct kind of lighting. I mean, that's hard. That's really, really hard. But I can see it as a means to fund research, because, you know, he got a special request to, you know, fake the moon landings. So who knows? But yeah, I really don't. I don't really have any doubt um, uh, that we did actually go. So yeah, yeah. Anyway, so no problem, Calvin. No problemo. We're, you know, we're here just having fun, and uh, that's it. You know, talking astronomy and actually getting back to Mars Insight. Okay, so all right. I thought that there were more experiments than just those two. Um, okay, it is going to be doing a radio science experiment, which has to do with actually using the radio signals that is sending the data and telemetry back and forth, right? They can actually use those radio signals to gather, you know, a lot of insight, apparently, into the internal structure of Mars. So that's kind of interesting, you know. So yeah, I just wanted to see where they were going to land because, as I thought, yeah, they've chosen a very benign location, right? I think wasn't there something about I want to say that there was something. This location was chosen too because of its either lack of seismicity or the opposite. Let's see, objectives. Let's see. They're not gonna. I don't know if they're gonna say anything about that. By studying the size, thickness, density, and overall structure of Mars's core, mantle, and crust, as well as the rate at which heat escapes from the planet's interior, InSight will provide a glimpse into the evolutionary processes of all the rocky planets in the inner solar system. It's just, you know, I mean, I understand, right? But I mean, we also have to understand that what they're saying there is like this huge extrapolation, right? I mean, it's a real stretch. They can do it though. It's okay. You know, I mean, if you set your parameters and your models, it's like, you know, do it. That's perfectly fine. Seismic activity. But yeah, I thought that the location was also chosen because of its seismic characteristics. I don't know. Yeah, it doesn't say.
The response and hopefully soft as soil was just a story as long as you realize the limitation, says Alcalada.
Yeah. Well, you know, having all the reconnaissance that we have now, you know, from HiRISE and other spacecraft, right? Other currently orbiting spacecraft. We've got a pretty good handle, I think, on at least the surface terrain, right? I mean, and to a certain extent, I would think, you know, being able to sort of get a pretty good understanding of what's underneath the surface too, to I don't know, a few inches, a foot, I don't know. So, but yeah, it's going to be an interesting mission. You know, another thing that I'd like to know is how Okay. So I was wondering about the mission duration, and it's planned to spend 2 years on Mars. I don't know if that's 2 Martian years or 2 Earth years. Don't know. Because they're pretty different. Gotta say, it was a beautiful launch. I remember it. Nice, nice, nice. So yeah.
Who brought that probe up to go to its destination?
To go through what?
What was that rocket that is going to bring that probe to Mars?
Oh, let's see. They launched it on an Atlas V from Vandenberg. So yeah, an Atlas V. So that'll give it a good push. And yeah, you know, the other thing.
Atlas V?
What is the Atlas V?
Yeah.
Well, here, let's just take a look.
Is that like SpaceX thing, or that's somebody else?
Let's see if we can do something even better than that. We can actually. Let's see. Here we go. This is the short version.
They launched it since May. Interesting.
Go inside. 5, 4, 3, 2.
Oh, it's ULA. What's ULA? University of Los Angeles?
All right, well, cool. No, ULA is United Launch Alliance.
Okay.
It's a rocket factory.
Oh.
Let's see.
Wow, a joint venture of Lockheed and Boeing.
Yep. Yeah. Well, you know, those two companies are pretty good at building rockets. So yeah, it's nice to have as many rockets as we can.
So eventually, like SpaceX, they build their own rockets and test them up, right?
Correct. Yeah, and so does soon Blue Origin. There's a New Zealand
How many
company.
third-party organizations that we got that can launch rockets?
In the United States, there's a few. I mean, no more than 10. Probably less than 10.
Okay, compare that to international organizations. How many more are we seeing?
Yeah, I mean, some countries do the rocket thing, and some countries don't. And the vast majority of them at this point don't. But it's growing all the time. So India is now on board. Japan, of course. China, Russia, United States, Canada. Sometimes like to hitch a ride. South Korea has astronauts. I don't think they've ever launched anything. I think that's about it in terms of launches. But pretty much every country has some kind of astronaut. Whether they've flown or not, is another thing. But anyway, so yeah, here's InSight. And yeah, it's going to be pretty exciting. You know, it's it's not going to be as much of a PR sell.
Yeah, thank you for mentioning that about that. The European Space Agency also does launches as well.
True. Yep. Yeah. Yeah. That's and
I think
that's
I've seen about a few ESA launches before too.
yeah, yeah, and ESA is sort of a conglomeration of I don't know how many countries now. Quite a few. I want to say like a dozen. Yeah, Rocket Factory. Yeah, well, there's as I said, there's a New Zealand company that I think they're called the Electron Rocket. Um, uh, they're going to be doing, they're going to be doing orbital launches, small payloads though, right? Small ones. So small rocket, small payload. Um, yeah, but lots of small payloads, no problem. Put some 8-inch telescopes up there. That'll be great. I'd love it. All right, well, cool. So, like I was saying, and I'm going to stop sharing here. I'm really thinking that this live stream could be much improved if there was a panel, right? And we could sit around, just like being on a porch, sitting around, shooting the breeze, thinking all kinds of astronomical thoughts, and having a discussion like that. And like I said, I mean, I don't mind. Talking astronomy for 60 minutes, 80 minutes, whatever it is. I can do that. It's easy, right? I mean, it comes naturally because I'm just sort of verbalizing my own thoughts. What's that?
Well, we got the chat up.
Chat. Yeah. India is doing some interesting things though, but the one thing that I sort of cringed at, Uncle Bill, do you remember the launch? Maybe it was a year ago or so, where India deployed how many of these little satellites? Was it? I don't want to say like, were there hundreds of them? I don't remember. And but I watched that, right? I watched a recording of it, and they were just shooting out like this, just right. And I'm cringing. I'm like, oh man, that is just littering. That's just nasty. They should be, their wrists must be slapped for that. But yeah, I think they're doing some amazing stuff. Yep, for sure. And China is doing amazing things too. And oh, I wish for the day when we can work together, because together we could do the most amazing things. I mean, it's synergy, right? I mean, that is, the definition of synergy is that, the combined effect is greater than the sum of the two individual parts. And if China and the United States, and everybody could work together, united in in lots of different kinds of projects, we would multiply our progress by orders of magnitude, right? It'd be absolutely fantastic, absolutely fantastic. So
wouldn't blame the launch provider for that. If he recalls correctly, the company that hired the launch, the satellite operator got fined, said Uncle Bill.
I wouldn't blame the launch provider for that. Oh, okay. Yeah, well, I guess you're right.
I know what happened around that time.
Yeah, the thing about those that I sort of didn't include, but I will now, is that those kinds of satellites decay very rapidly, right? So I mean, they're down in a few months, and even if it's a couple years, that's okay too. I mean, they're eventually gone, right? They burn up in the atmosphere, gone, turn to dust, to pollute the, the atmosphere up there. So, yeah, it was just, I don't know. I just sort of cringed when I saw that because it's just like, wow, that's a lot of stuff. But what made me cringe even more, right, was when China collided two of its satellites on purpose, and out at an altitude, I think of something like 900 kilometers, which means that stuff, those millions of pieces, right? I mean, these things collided at very high velocity.
Yeah, the company was called Mircan.
Okay, cool. But yeah, these two satellites, they collided at high speed, right? At high speed.
I wonder who's stupider, China or Cuba?
Well, China did that mainly just to show everybody that they could. But that was dumb. That was really, I mean, that's bad for all of us, right? Because that stuff, like I said, at that distance, that is going to be up there forever, right? It's never coming down, ever. I mean, there's going to be a few fragments, right, that are sort of aimed toward, down, but besides that, nope. So yeah, that was really, really dumb. That was really, really dumb. But yeah, seeing that Indian deployment of just one satellite after another, just boom, boom, was yeah, that was hard to watch. That was almost as hard to watch as Uncle Bill. What was it was the Parker Solar Probe. That was a white knuckle 5-minute interval, right? They launched, right? Good launch. Good second stage. But as soon as the third stage ignited, they lost telemetry. And they did not have telemetry for, at least 5 minutes or so. And, man, they of course showed, the video in the control room, and everybody's just like frozen, right? Waiting.
Yeah, everybody was like, what the deuce?
Well, yeah, because, when it's about to fire its third stage, okay, that rocket is out of sight, right? It's out over the Atlantic, but it's over the horizon of well, of Van, or where's I guess
Now I
Parker
wonder
Solar
how's
Probe.
that Parker Solar Probe is doing.
As far as I know, it's doing well. It's I saw something about it's turning instruments on, and it's actually getting data. It's sort of seen first light. So yeah, I think it is ready to go. It's going to be passing by Venus here really soon, like super soon.
I wonder if they're going to publicize that data, so we can
Yeah,
all see it in a future episode.
yeah, that those kinds of questions are oftentimes asked at the press conferences now, and I believe that question was asked, and as I recall, the answer was that data is going to be made available like almost immediately after it's collected. So, or sent, right? Because it's likely going to be collecting data, storing it, on some kind of internal system, and then at a better time, perhaps it'll beam all that data back to Earth. But I think the plan is to make that like available right away. I think. So cheers.
Yeah. Is it hydrogen hydroxide or H2O?
This is hydrogen hydroxide. Yes. Yeah, it's that's my go-to for sure, for sure. Now, if I want, a little bit more of a pep, then I go for the dihydrogen monoxide. Yeah, but those are sort of on special occasions. For me here, I'm over in um, southeastern Arizona in the United States. Uh, I am always Mountain Standard Time, so that's 7 hours behind UTC. So when Astronomy Daily Live starts at 2 hours UTC, it's actually 7 p.m. my local time. And since that's my local time, I'm sort of winding down, right? So, to have a peppy kind of consumable this time of day, it'll just keep me up for hours. So cheers. Anyway, so and I'm going to mention this until it starts to happen, I guess. And that is, I would definitely like to have a large panel. Large panel. I think that'll make this live stream something pretty unique in terms of astronomy live streams, and yeah, I think it'll make it better for sure, for sure. So, and that's what I'm trying to do, right? Is always think about ways to make this better, and I think that definitely would. So, definitely could use your help on that. It's all you need is a microphone, right? You don't have to do the video thing. It's all you need is a mic, and yeah. So if you're interested in that, if you're interested in making this better, I mean, you can have sort of a hand in that, right? By getting on the panel, and we'll treat this more like a virtual porch where we're just sitting together in our lounge chairs, right, with our consumables at hand, and talk astronomy.
Remember I was talking about like who's worse, Cuba or China?
Yeah.
Cuba's usually worse when it comes to shortwave radio transmissions.
Yeah, yeah. Does Cuba jam as much as China does, though?
I know they'll jam like 99.55, Radio Marti, and I think another station too.
Yeah. Pretty funny. Yeah, I mean, you know, look, people, we do all need to try to get along a little bit, and it's
I know,
absolutely
well, you did mention China. I think also like Iran jams as well.
yeah.
And North Korea.
Doesn't the United States jam?
I don't think so.
Why wouldn't we? I don't know. I don't know. But I mean, if everybody else is and we're not, that doesn't make any sense. I don't know. I'm thinking that we probably are, but I don't know why we would. I don't know. So yeah. Anyway, so yeah, you know, I'm looking for ways, you know, to make improvements here, and you can definitely help. So the way to get started is to send me an email. It's cosmiclettuce, all one word, at gmail.com. And, you know, just tell me, you know, that you want to be part of the panel. And then what'll happen?
And you don't have to randomly generate links every single day and like have just one big one. They can just join at any time, right? Or
no, I think I have to send out the invite. Yeah. So, and
yeah.
That's what I'll do, right? Once I start my live stream panel, which I usually start about 15 minutes before 2 hours UTC. So at 1:45 UTC, I start up my live stream panel here, and that creates a link, a web link, and I send that link to you, and then I guess, right, I mean, you click on that link and it connects through some kind of magic.
Yeah.
And that's it, right?
I know
So,
you gotta like accept the terms and conditions, and then you gotta click on that green join button.
okay. Yeah, I've never myself been on a panel, so I've never been a panelist. Maybe someday. Who knows? So, all right. Well, cool. Let's see. Well, we looked at Mars Inside for sure. You know, I think I do want to cover this one kind of interesting thing that I saw. It was a new paper over at archive.org, and let me see. Did I? Okay, did. Okay. So here, I'm going to share my screen. Have to sing a song while I'm sharing my screen. Okay, share the screen. Go to infinity, which I like. I think it's extremely interesting going to infinity. So this paper, really short, right? It's the rotation curve of the Milky Way from classical Cepheids. So Cepheids are variable stars that have this interesting correlation between how bright they are and their period of variability, right? So it's a variable star. Cepheids, I think, are, they are single stars that are expanding and contracting, right? So getting bigger and smaller and bigger and smaller. And that frequency correlates with how bright they are. Intrinsically bright, so their luminosity. So they can come up with this period luminosity function. Well, if that's true, if that works, right, then what you can do is you can use a Cepheid variable star as what's called a standard candle. Because if there is some kind of relationship between the luminosity or brightness of this star and its variability period, then if you can measure that period of variability, then you can calculate what the luminosity is. And if you know how bright it is, then you know how far away it is. And distance is a tricky thing, right? I mean, the only for sure way to be able to measure distances is with parallax. Every other way of measuring distances has to do with some kind of model, some kind of guess. So anyway, so what they can do is they can look at the distances to these stars and then measure their velocity and see what they get. So that's what they've done here. And this kind of data is actually used to well, it was used to consider the concept of dark matter, because the idea there is that the motions of stars around the centers of the galaxy should behave in a particular way, and they found that it doesn't behave that way, and so they came up with this concept of dark matter. So anyway, this is just a little bit more data to show you, just to give you an idea of what's going on, we think, with our own galaxy. So this, of course, is the distance from the center of the galaxy, and it doesn't really matter what the distance is, but they've marked it out here. So this is 0, this is 20,000 parsecs. So 20,000 parsecs is about 70,000, is that right? 70,000 light years? I guess so, yeah. Well, that's kind of interesting. Let me look at that. Let me just do 20,000. I'll grab the calculator again. Times 3.26. Oh, 20,000 times 3.26. That's 65,200 light years. Huh, okay. So it's sort of looking like maybe the edge of the galaxy is about 15,000 parsecs. But that's still, wow, that's a lot bigger than what I thought. Times 3.26. That's almost 50,000 light years. Well, I guess that's about right then. Yeah, okay. So this is sort of the edge, what we would call, the edge of the galaxy, where the density of stars sort of almost vanishes there. There's some extraneous ones way out there. And then along this axis is the total velocity. So that's an X, Y, and Z in kilometers per second, right? So we calculated this the other day, right? And I think we came up with something really close to that. Don't remember exactly. And I guess they're showing data from two different sources. The gray here, which is kind of hard to see, is from a paper back in 2009. And then all the blue dots here is data from this work. So, as you can see, you know, the total velocity here, in general, looks pretty flat. Pretty flat. There's a little, maybe a little bit of a bulge here, and maybe some structure in there. It's really hard to tell, right? Because Cepheid variable stars aren't everywhere, right? There's a limited number of them. I wonder how many they used in this one. We can probably find out.
See you tomorrow, Atalanta.
Bye-bye, Atta. Nice to have you back. Okay, so for the modeling, 774. So they use 774 Cepheids. That's cool. That's a good sample, right? That's a pretty good sample. So pretty interesting, right? Pretty interesting. You can see from this other data set how the velocities vary as it sort of gets closer in here. Some really interesting things going on there, right? But then what I thought was kind of neat too were these plots. So these are the non-circular motions. So taken with sort of two different models. And I guess the models would be, you know, that period luminosity relationship. You know, depending on what model you use there, the distances are different and all kinds of other things then change. But what they're doing here, so here's model 1, here's model 2. You know, comparing the two, I don't know, they look about the same to me. I mean, yeah, subtle differences. Maybe, you know, they point out things in the text that I'm not seeing, but I'm not really seeing too much of a difference between these two models. Yeah. But what I thought was really, really cool was what this data actually is. So U sub S, which are these two plots, the top ones, is the velocity component toward the galactic center. So it's like a radial velocity. And as you can see, I mean, there's quite a spread here, right? Some of them are going away from the center, right? All the negative ones. Some of them are going towards the center, all the positive ones. So that's kind of interesting, right? But then it's kind of neat because there is some pretty visible structure here, right? Maybe there's some clumping. There's this like little dip here. Maybe there's a dip here too. It's really interesting, you know. So that's how these Cepheid variable stars are moving radially. So then V sub S, which is the next one down, is along the galactic rotation. So that's kind of interesting that it's a really interesting perspective, which is why I wanted to share it with you folks, because you know, I like these kinds of things. I like different kinds of perspectives. I'm going to zoom in a little bit on that and see a little bit better. So when the velocity here is negative, that means that it's going against the rotation of the galaxy. And when they're positive, they're going with the rotation. So all these guys down here are going upstream. Kind of interesting. And it looks to me that there's a lot more going upstream than going downstream. So yeah, that's kind of interesting. And then let's see, this last one, W sub S, is the motion towards the North Galactic Pole. Okay, so these are moving either towards or away from the pole, which I guess is sort of a measure of the of sort of, you know, the z-axis, the vertical motion of these stars in the galaxy. So moving positive would be moving up out of the disk, and moving negative would be moving down out of the disk. Regardless, they're moving out of the disk. But you can see, you know, that the scale here is the same, right? Negative 50 to 50 on all three of these. And it's very obvious that this towards the North Galactic Pole motion is a lot smaller than these. See how tight and compact that width is compared to these. So yeah, just it's an interesting perspective on the motion of, well, at least 774 Cepheid variables. I don't know how they may talk about it in the paper. I didn't really look how they selected these. Yeah, I don't know. I just thought it was interesting. I wanted to share it with you. But I think that for now, it is time to exit. Yeah, I think it's time to get out of here. So thanks for coming in, everybody. Cheers. Have a great evening, a great day. And yeah, I think I will definitely be here tomorrow. So take care, everybody. Make sure to subscribe, hit the thumbs up or thumbs down, make some comments. All right. I will see you again soon. Take care. Bye.